All right, welcome. In this explainer, we're going to jump right in and close the gap between clicking around in the Azure portal and building a really powerful automated workflow using infrastructure as code. We're going to grab the tools, connect them up securely, and get them ready for a full-on CI/CD pipeline.
I mean, we've all been there, right? You spend an entire afternoon just clicking through menus to set up a virtual machine, a network, a database. You know the pain. It's slow, it's so repetitive, and if you make one wrong click, well, that can lead to hours of headaches. But there is a much, much better way.
And this is it. On the left, that's the old world. Slow, totally prone to human error, and good luck trying to track who changed what and when. But on the right, that's infrastructure as code, or IaC. It's fast, it's automated, and because your entire setup is defined in code files, it becomes repeatable, consistent, and you can version control it and audit it, just like your application code.
Okay, so to get started, we need to assemble our toolkit. These are the command line powerhouses that are going to form the foundation of our whole workflow.
First up, the star of the show, Terraform. This is the tool that lets us just write down, in a really simple language, what we want our cloud to look like. I want a resource group, a storage account, and a Kubernetes cluster. Then, Terraform is the genius that goes and figures out exactly how to build it all.
Next, we've got the Azure CLI. Now, while Terraform is going to handle the big picture, we still need a way to talk directly to Azure for specific tasks, like logging in for the first time or creating the credentials our automation needs. The Azure CLI is basically our Swiss Army knife for all those little jobs.
Of course, all this infrastructure is pointless if we don't have an application to run on it, right? That's where Docker comes in. It lets us package up our apps with all their dependencies into these neat little boxes called containers. This is huge because it guarantees that the app we build on our laptop is going to run the exact same way in the cloud.
And finally, once Terraform builds that awesome Kubernetes cluster for us, we need a way to actually interact with it. That's kubectl. It is the universal remote control for talking to any Kubernetes cluster, anywhere, letting us deploy and manage our applications.
Now, with Terraform, you're going to find yourself doing this little three-step dance all the time. First, Terraform plan. Think of this as your dress rehearsal. It shows you exactly what's about to be created, changed, or even deleted without actually doing anything. Once you're happy with the plan, you run Terraform apply. That's showtime. It makes it all real. And when you're done, Terraform destroy tears down the whole set. Plan, apply, destroy. That's the loop. So, we've got our tools. Now we need to actually connect them to our Azure account, and we have to do it securely. This step is absolutely crucial for enabling all the automation that comes next. When it comes to logging in, there are basically two ways to do it. There's the way for us humans and the way for our robots. For us, on our local computer, we just type as you log in. You know the drill. A browser pops up, you sign in, and you're good to go. But for our automation, like a GitHub action, you can't have a browser window popping up in a server somewhere. For that, we need a special, non-human account called a service principal. So what on earth is a service principal? Honestly, the best analogy is to think of it like a robot valet. You wouldn't give a valet the master key to your entire house, would you? No. You give them a special key card that only opens the garage door. A service principal is exactly that. It's the limited access key card you give to your automation with just enough permissions to do its job and absolutely nothing more.
And this quote right here, this is the absolute golden rule of cloud security, the principle of least privilege. All it means is that you should never, ever give an account, whether it's for a person or a robot, more permissions than it absolutely needs to do its job. It's a simple idea, but it dramatically minimizes the damage if credentials ever get compromised.
And here is that exact principle in action. Check out this command. We're creating a service principal, sure, but look really closely at that -scopes flag at the end. We are not giving it permissions across our entire Azure subscription. No way. We're scoping it down to one single resource group. That is least privilege, perfectly executed. So after you run that command, the Azure CLI is going to spit out this block of JSON text. And let me tell you, this thing is gold. It's got the ID, the secret password, all the details your automation needs to log in. You have to treat this entire chunk of text like a top secret password, because that's exactly what it is. We're about to see where it goes. Okay, hang on. Before we actually create our first resource, we have to talk about something called state. It's a super important concept. It's how Terraform keeps track of everything it's managing for you. You can think of Terraform's state file as its memory, or its brain.
It's basically a giant map that connects the resource definitions in your code files to the actual resources running out there in Azure. Without this state file, Terraform would have amnesia. It would have no idea what it's supposed to be managing. It's the single source of truth.
So here's the catch. By default, Terraform just creates this state file right there on your local machine, which immediately brings up a huge question. What happens when your teammate needs to make a change? How do they get your version of the file? And what happens if you both try to run a change at the exact same time?
Yeah, as you can probably imagine, keeping that state file on your laptop is a recipe for disaster on any real project. It makes it impossible for teams to collaborate, it can get corrupted if two people run changes at once, and since that file can sometimes contain sensitive data, you really don't want it just sitting around on a laptop. So what's the fix? It's actually pretty simple. We use what's called a remote backend. With just this little block of code, we're telling Terraform, hey, don't save that state file here on my machine. Instead, I want you to save it in this specific container inside this specific Azure storage account. This gives us a central, secure, and shared location. Plus, Azure Storage has a locking feature, which is critical. It prevents you and a teammate from running Terraform Apply at the same time and totally messing up your state.
Okay. Deep breath, we have our tools, we have a secure connection, and we have a safe place to store our state. Now it is time for the grand finale. Let's put all these pieces together and automate the whole darn thing.
This little snippet from a GitHub Actions workflow file. This is where all the magic comes together. We're using a pre-built action called Azure/login. And see that creds input? It's pulling a value from something called secrets.azurecredentials. And guess what we're going to put in that secret?
That's right. The entire JSON object we got when we created our service principal. We copy and paste that whole thing into a GitHub secret named Azure Credentials. The Azure/login action is smart. It knows how to read that JSON, pull out the client ID, the client secret, and all the other details it needs to authenticate with Azure automatically. This is how our robot gets permission to run Terraform for us.
So, let's just boil all this down. What are the big takeaways? First, automate everything you possibly can with infrastructure as code. Second, and this is a big one, always apply the principle of least privilege to your service principals. Third, never ever use local state for a real project. Use a remote backend like Azure Storage. And finally, remember that the ultimate goal here is to plug all of this into a CI/CD pipeline for true hands-off automation.
Look, when you start treating your infrastructure like code, you fundamentally change the game. You've unlocked a whole new level of power, consistency, and speed. You're not just clicking buttons in a portal anymore. You're developing infrastructure. The whole process is now as reliable and repeatable as your application builds. So the only question left is, what amazing things are you going to build with this power?